In this video, we're going to explore how to use StatCrunch to analyze two sample studies. We're going to consider an example where we have data from two different kinds of batteries. We have 6 randomly selected brand name batteries and 6 randomly selected generic batteries. We put the batteries, AA batteries, into the flashlights and record the time in minutes that the batteries last. We'd like to test the null hypothesis of no difference in the mean battery life of the brand name and generic batteries, and would also like to establish a 95% confidence interval for the average difference in life between the two batteries. I've typed the data into StatCrunch. To perform the hypothesis test, I'm going to go under Stat, T-statistic, to sample with the data because I have the raw data. Sample 1 is in column 1, which I've called brand name, and sample 2 is in column 2, which I've called generic. I want to test the hypothesis of no mean difference in average battery life, and the alternative will be a two-tailed not equal to. And now let's just calculate. And here are the results. The p-value is a 0.0298, or approximately a 0.03. This is less than 0.05, so we're going to be rejecting the null hypothesis that the two population means are equal, and going with the alternative that there is a significant difference in the average battery lives. The t-statistic is negative. Since we put in brand name first and generic second, that means that the brand name has a smaller average than the generic, or conversely, that the generic's average battery life is longer than the brand name, and the p-value associated with that conclusion is 0.03. To establish the 95% confidence interval, I'm going to rerun the analysis. I'm going to do stat, t-statistics, to sample with data. Since the value of the t-statistic was negative, I'm going to turn things around this time. I'm going to have generic be sample 1 and brand name be sample 2 because it's easier to interpret positive differences. Next, I'm going to click on confidence interval, and if I want a 95% interval, I'll leave it set at 0.95. Let's calculate. So we can say that on average, the mean battery life of generic batteries is somewhere between 2.3 minutes and 35.9 minutes longer than the average battery life of brand name batteries. And this is a statement we can make with 95% confidence. What if we had not been given the raw data, but rather the summary statistics? That is, we had been given both the average and standard deviation for the battery life of both brand name and generic batteries. In this case, we would go under Stat, T-statistic, to sample, and this time we don't have the data, but we have the summary statistics. They want us to enter the sample variance, The sample mean for the generic batteries is larger than that for the brand name, so I'm going to let sample 1 be generic. The sample mean is 206.52 minutes. The standard deviation is 11.29 minutes, and the sample size is 6. For the brand name batteries, the sample mean is 187.43 minutes. The standard deviation is 14.61 minutes, and the sample size is 6. We want to test the null hypothesis that there is no difference in the average battery life against the alternative that there is a difference. And then we do calculate. And once again, we get a p-value of about 0.03, which is statistically significant. And we are again going to conclude that on average, generic batteries last longer than brand name batteries with a p-value of 0.03. Next, we consider an analysis or an example involving paired data. So a company is switching from a 5-day work week to a 4-day work week, and they want to see if employees drive less after the switch. So they have recorded the annual miles for 11 employees. It's paired because each value in column 1 is naturally paired with the value in column 2 because it is taken on the same individual. I've taken and typed the data into StatCrunch. If I want to change the column labels, I can click on variable 1, delete it, and type 5-day. I can click on variable 2 and delete it and type 4-day. When it comes to the analysis, I'm going to go under the Stat menu. I'm going to pick T-statistic, and this time I'm going to pick paired. Sample 1 is the 5-day week. Sample 2 is the 4-day week. I'm testing the null hypothesis that there is no difference in the average number of miles driven between the 4- and 5-day week. My alternative, however, is going to be a greater than, because if anything, it seems as if you need to drive an extra day to go to work, you should be driving more annually. I'm going to go to calculate. The p-value is small. It's 0.0085. It is less than 0.05, so we're going to reject the null hypothesis and conclude that the annual average miles driven on a 5-day work week is longer or more miles than on a 4-day work week. I can redo the analysis to get the confidence interval. T-statistic paired. And we are going to do 5-day versus 4-day. This time, click confidence interval and set your confidence level. I'm choosing to set it at 0.95 and then calculate. Here are the boundary values for the 95% confidence interval. So we can state with 95% confidence that on average, employees will drive somewhere between 216 miles and 1,747 miles more on a 5-day work week than on a 4-day work week.